Hello, everybody. Here we are, 7.4 similar triangles. This is the last thing we'll do from Math 9, but I think it's going to be helpful as we start trigonometry. So a similar triangle, I'm going to mention what a similar polygon, similar polygon needs both equal angles and proportional side lengths. So we need both of these to be true. Because you can imagine, say you have, you can have a rectangle that, all of those angles are the same. They're all 90-degree angles, but they might not necessarily be similar because their side lengths might not be, in the same proportion to each other. So they're not an enlargement of each other or a shrinking of each other, even though they have the same angles. But for similar triangles, you only need to be able to show that you have that the angles are equal, so that P would equal S, and that T would equal Q, and that R would equal U, to know that they are similar. Because triangle is a special type of polygon. Where if all of the angles are the same, then the sides will be proportional as well. So that also means that if you can show that the sides are proportional, that you know that the angles are the same. So this is an or, where all polygons, other polygons, you need both. For a triangle, you just need to show that either all of the angles are the same or that the side lengths are proportional. So let's go number 1. Identify the similar triangles in the following diagrams. Equal angles are marked on the diagram. So when we list a triangle, we need to list them in the same order. So if we started, say, with this one that just has a single line, we can write that down first. And then we move to the right angle, O, and then we follow it over to the 2-line angle. We got dog. And this is going to be equal to, here we have to start with the single line over here, T, move to the right angle, A, and then move to the C for tack. So you might be, tempted to do dog and cat, but it needs to go in the same order. So for this one, if we start with this double line, we go R, we move to the single line for the U, and then we move to the circle for the N. That's equal to, if we start here with the G, we move to the single line for the U, and we finally move to the circle for the M. And the last one, say we want to start, I don't know, with this M here, the double line, move to the circle for A, and finish at the angle G. That's a G. That's equal to, we'd have to start at angle P with the 2 lines, move to angle A, P, A, and then move to the single line for T. Okay, so you have to go in the order, or else you're looking at 2 different triangles. Let's see, determine the length of XY in each pair of similar triangles. We know they're similar. They say that piece of information. So what we can assume to be true is that all of the side lengths will be in proportion to each other. So we need to find we need to find what that ratio is. And so you notice on these 2 triangles, we have 2 kind of missing pieces of information. This length right here is missing. We don't know that. That's a question mark. This one is also missing. That's also a question mark. However, it's asked us for x, y. So we really only need to solve this one mystery, this one right here. We only need to solve that mystery, x, y. So RQ is a little bit irrelevant to us. So let's just solve for x, y. So we have these 2 similar pieces of information. We don't have anything to compare 9 to, but we do have something to compare 6 to. So the ratio from this triangle to this triangle is 6 to 4. And we know these are in proportion because we know it's a similar triangle. So we can show this ratio as a fraction, 6 over 4. If you want to turn this into a decimal, you can. 6 divided by 4 is 1.5. So we know that every side length over here, if we want to go this way, we need to multiply it multiply by 1.5. So, I mean, we can do that. All we need to know is that, 8 times 1.5 is going to give us our xy. So 8 times 1.5 equals 12 centimeters. We can also set it up as like equal proportions. So we can have it as 6 over 4 is equal to, we don't know. This would be the angle right here, xy, over 8. So we know the kind of corresponding number for the two triangles. We know the 6 on this side, but we don't know what xy is. And then we can cross multiply and divide to find out the value of xy. So divide by that 4. And you'll notice, okay, we have 6 times 8, which is 48. 48 divided by 4 equals 12 centimeters. So we got there. Either way is fine. Let's do the next one. We have to find out, just look a little bit about what each of the lengths is asking us for. We know this value, and we know this length right here. Oh, first we're looking for xy. So this is our mystery over here. That's our mystery. We know this length, and we know actually the whole length. So we know that little bit, and we know this whole length because it's shown us that it's 5 plus this section right there, 4.5. So we know the ratio is a 5 to 5 plus 4.5 is 9.5. So we can show this as a fraction, 5 over 9.5. And that is equal to, let's see, 2.5 over x. 2.5 over we don't know. So you want to line it up when you set up an equation like this. These are from the same triangle right here, the 5 and the 2.5. So we're going to line those up across from each other. And the 9 is lined up with our question, or 9.5 is lined up with our question mark. This and this go together, so we line it up with our question mark. Now we can cross multiply and divide. So you always multiply across the two numbers and then divide by the third number. So let's go, let me get my calculator. 9.5 times 2.5 equals 23.75 divided by our last number 5 equals 4.75. So x equals 4.75 centimeters right there, 4.75. Does that make sense? I would say that makes sense, right? I think it kind of, you could show it exactly to check. We should get the same ratio. So if we go 5 divided by 9.5, 0.5263, and then let's try it again, 2.5 divided by 4.75, 52.63. So there you go. They're in proportion, and we can check that we have the correct answer. Let's do this last question together. A surveyor wants to determine the width of a river. She measures distance and angles on land and sketches this diagram. What's the width of river PQ? So we're looking for this part. We're looking for this part right here. How wide is the river? That's our question mark. And we know this is a 15, which correlates. You imagine swinging this triangle around this way. So this 15 lines up with the 12, and the 20 is going to line up with our question mark. So we know that 15 over 20 is equal to the 12. We know those are the two that are lined up together. We know these are in proportion. 12 over we don't know. So now we can cross multiply and divide by the third one. So let's do it. That's my calculator. 12 times 20, 240, divided by our last one, 15, equals 16. So x equals 16. And I would say that makes sense, right? So the ratio we can check is the ratio 15 divided by 20. 15 divided by 20. Oops. 15 divided by 20. 0.75. Is that the same as the ratio of 12 divided by 16? And you see that it is. So you can check that you got the right answer. So the distance there I should write is 16 meters. Okay, I'll let you folks know which textbook questions I want you to do. You don't have the Math 9 textbook, so I printed it for you. Thank you so much.